We're going to learn how to rearrange Pythagoras' theorem so we can find the shorter side of right-angled triangles when the shorter side is unknown. Now, if you have a look at what's on the board here, at the very top we have Pythagoras' theorem, c squared equals a squared plus b squared. All I have done is I've subtracted b squared from both sides of the equation. This has given us c squared minus b squared equals a squared. Then I've rotated it around the equality sign, so the equals. So it becomes a squared equals c squared minus b squared. Now, if we were in the situation where we were trying to find b squared and not c squared, then Harry, could I borrow that marker, please?
Yeah, I got it to work, sir. Can you catch?
Yeah.
Maybe you can. Got those moves. Can I have it back now? No. Because I got it to work, so I should have it back. Learn to catch.
We have two forms of the equation. They're equivalent to one another. You can interchange a and b. It doesn't matter which one's a, which one's b. But these are two forms of the formula that you may choose to use.
What does that say?
Calculate shorter sides. Okay, now let's have a look at the application of this. It is very similar to the application of the hypotenuse. Suppose a random triangle suddenly appeared.
So, do you want this back?
Find the value of the unknown. We've got a and a random triangle suddenly appeared. The triangle was defined as being a right angle because there was a right angle right here. Secondly, the triangle is defined as having a hypotenuse of, what's your favorite number, Morgan? What are you cooking for your friends? You will need 37 kilos of chicken to feed an army.
No, you won't.
And you'll need 15 kilos on this side here. What we want to do is we want to discover the value of x. Now, looking at this triangle here, this probably seems pretty doable considering what we've been doing the last lesson or so. But then we look at it and we label it and we're like, hypotenuse is there, so therefore C must be here. And then A, B. C must be there. And we discover that C is actually known and A is unknown. So all of a sudden the form is different. Any ideas? What could we do to be able to solve this? Zoe?
B2 equals C2 take A2.
Yeah, we can employ the formula A squared equals C squared minus B squared. And then it's simply a matter of substituting the values you already have. So whenever we see A, we know that that's going to be X. Whenever we see C, it's going to be 37. And then whenever we see B, it's going to be 15. Now, in the past I've told you, just calculate it in piece rate, do 37 squared, write it down, do 15 squared, write it down, go to the next line. There is a shorter way to do this. If you wanted to, and if this is appropriate for you, you can take the square root of both sides from the get-go, and you can go x equals the square root of 37 squared minus 15 squared. However, if you choose to go down this route, on the calculators we're using, those lovely Sharp calculators, you're going to have to put in the brackets where I put it in green. For our notation, we don't need those green brackets, but for your calculators to function correctly, you'll need to add those in. Does anyone want to plug that in the calculator and show us what you get? 39.92. Are we sure about that?
Square
Square it.
Square
What is the largest side in a triangle?
37.
Starts with H.
Hypotenuse.
Hypotenuse. If your value is larger than the hypotenuse, do you think your answer is correct?
Yeah.
Did you do a subtract or did you add them?
Yeah.
Try again.
33.
33.82.
That's what I got.
Why did you say that then?
Wait, no. He got 39. Oh.
Juju, what did you get?
I got 33.82.
33.82.
If you do that, then you get a different answer to if you do it just 37 squared minus 15 squared, and then you square root it.
33.82, or we can just go 33.8. And of course we put the units. So what we discover is that by labeling the triangle, substituting the values into the alternate formula for Pythagoras' theorem, we discover that the unknown shorter side is equal to 38 or 33.8 kilograms. Does anyone remember why we can use kilograms in these problems?
What did you say?
Because
Pythagoras' theorem is not just limited to distances.
37 squared minus
It can have weight or mass.
That's fine.
Are there any questions, guys?
no.
Do we want a different question? to
Can we
look
get
at?
harder?
You want to get something
No.
trickier,
No.
more complicated?
Yeah.
Alright, I wasn't going to do this one, but we'll do it now.
Can we please do it later?
No, I want to do it now.
No, not everything's about you.
oh.
Okay, we're going to do something trickier. This relates to the final few questions in the questions I'm going to assign you. Example 2.
It's okay.
Did you see that?
I'm gonna ugly like a loser.
Maximum focus, please. We're going to show the triangle ABC is right angled or not. Triangle ABC
Could I please borrow your lemon?
is here. Triangle ABC.
I can't do it.
Triangle ABC is going to be defined as having, do it in black. A, B, C. And it's going to have the side lengths,
24. So?
3, 4, and 5.
Oh, that's easy.
We want to know, is this triangle right angled or not? I warn you, it's not drawn to scale. Any ideas, guys? Right angled triangles. Do we have a rule of some sort that tells us the relationship between sides of a triangle?
What is it then?
Have we been using some sort of rule the last 2 and a bit lessons?
Cubes.
Cubes.
That maybe some famous person who came up with some sort
Albert
of
Einstein.
famous theorem related to triangles?
Mr. Anderson.
Thomas Edison.
Pythagoras?
Pythagoras, my man. We can use Pythagoras' theorem to show whether a triangle is right angled or not. Now, if we observe this triangle here, if it's right angled, there's got to be a right angle somewhere. But before there's a right angle, there's probably a hypotenuse. What property does the hypotenuse in a triangle always have? It's got to do with its length.
The longest side?
It's always the longest side. Now, if this is a right angled triangle, which side would have to be the longest? Would it be AB, BC, or
BC.
AC?
BC.
AC is longest. So I might say, if triangle ABC is right angled,
Oh, it was A all the way to C. Is that in
then side length AC is hypotenuse. Listening, please.
So can I have another colour texture?
If triangle ABC, triangle ABC is right angled, then side length AC must be the hypotenuse because AC is the longest. Now, if this is right angled, then what we're going to discover is that C squared equals A squared plus B squared, where this is going to be C, this could be A, this could be B. It doesn't really matter A and B, so long as C is on the longest. Next, what we're going to discover is that AC squared is equal to A, which we said was BC squared, plus AB squared. There's a lot of different notation here, guys. Now, this is our statement. What we're going to do is we're going to show that one side is the same as the other side. I'm going to pick this side here. The right hand side is equal to BC squared plus AB squared. What is the length of BC, Izzy?
BBC.
BC, how big is it? BC, how long is BC?
Are you asking me?
Yes,
4.
4. And then Posey, how long is the side length AB? AB, 3. 4 squared plus 3 squared is going to be 16 plus 9, which is 25. So that's our right hand side. What about our left hand side? Our left hand side is going to be AC. How long is AC, Nathaniel?
5.
5. So it's 5 squared. What's 5 squared? 25. And you see that the right hand side and the left hand side are equal. LHS is the same as RHS, or left hand side is the same as right hand side. Therefore, triangle ABC is right angled. A lot of notation on the board, isn't there?
Yeah. Oh my goodness.
Do you think I'm going to say you have to remember all of that notation and show these proofs or show
No.
these shows
Yes.
exactly like I've shown?
Yeah, probably.
Or do you think I'm just going to say, guys, if you ever saw something like this in a test, give me some sort of explanation as to what's going on there?
Yes.
Some sort of explanation.
Yeah, some sort of explanation is good enough. You don't have to show things out in the wild. You don't have to prove them out in the wild. You just need to know the relationship and know how to check for it.
So I don't have to explain how I got my answer?
No.
No.
That's good.
You would in just one sentence. Just say using Pythagoras' theorem, both sides are equal. Or the relationship works.
Why would you
Or
have to
balance.
explain it in the wild?
Just in case you're trying to see if a roof is square or not. Now, this one's a bit peculiar, guys, because the right angle is there. The triangle's been skewed in three-dimensional space to look like it's not a right angle, but there's a right angle there. Alright, any questions?
Guys, this
Slap,
the easiest
slap.
math I've
That's right
done.
angle.
It's because you're listening.
She keeps
Alright,
giving me
jolly
the
good.
side.